Hi, folks, and welcome to the kickoff of a new monthly series called DevOps Best Practices. The goal of this series is to share the things that we've learned, all about accelerating software development and delivery. We plan to have a session each month dedicated to delivering high-quality DevOps outcomes using Google Cloud. My name is Sandeep, and I'm a DevRel Engineer focused on helping teams adopt better DevOps strategies. I've been with Google Cloud for about 7 years, minus a little time away, helping teams of all shapes and sizes adopt and optimize for cloud. You can always find me at CRCSMNKY on Twitter if you've got questions or comments about DevOps, Google Cloud, or you just want to say hi. Now, about 5 years ago, while discussing his company's DevOps transformation journey, the CIO of Alaska Airlines at the time declared that they were no longer an airline company, but instead considered themselves a software company with wings. And this is a trend we're seeing across industries of all types. Software is a key aspect of delivering innovation and value to customers across the board. Now, if you go to Google and search, every company is and let the word fill in the blank, you actually start to see that we are witnessing a shift in the way companies identify and think of the role that software plays in their businesses. Software has become this sort of unit of value, right? It's how you respond to market changes. It's how you compete with your competition. And so I think a lot of companies are asking themselves, how do we get better at developing and delivering software? So before we can improve, we've got to start with how we can measure that software delivery performance. And that measurement starts with developing a better understanding of DevOps, and that's where DORA comes in. DORA stands for DevOps Research and Assessment, and it is the largest and longest running research project of its kind. DORA's goal is really to provide an independent and tool-agnostic view into the practices and capabilities that drive software delivery performance. Now, for the last several years, DORA has been running annual surveys, collecting and analyzing a whole bunch of data from IT teams. And the research project has used that data to develop a whole bunch of insights about the most effective and efficient ways to develop and deliver software. There have been several key findings that have emerged from that data, and we're going to spend a little bit of time here going through them in this kickoff session. But among the things that we've learned is that there are actually some simple and straightforward ways to measure delivery performance. And we know what positively and negatively impacts that performance. We also know that it goes well beyond just tools and technology, that there are process, management, and cultural capabilities that really impact performance. And finally, we know that community structures and focused leadership are the best ways to start and see a DevOps transformation all the way through. So, how do we measure software delivery performance? Well, in the research program, we were able to find a valid and pretty reliable way to do this. There are 2 metrics that represent speed and 2 metrics that represent stability. Starting with speed, we measure the frequency of delivering new deployments and the lead time for changes to go from commit to production or to release. And then for stability, we have change fail rate, which measures the number of changes you ship that lead to failures, and the time needed to restore things to a functional state. These 4 metrics can be applied to any kind of software delivery, including firmware, mobile, etc. So we have the measurements, and we have a lot of data about software delivery performance across the industry. We also have this tool called the DORA Quick Check. And just by answering 5 questions, you can actually benchmark your own performance across your own industry and across all industries in terms of software delivery performance. And once you complete that quick check, not only can it benchmark you, but it also tells you where you fall into from a category perspective. Because through the data, we've actually been able to kind of bucket teams into low, medium, high, and elite performance categories. Now, I know low sounds bad, but I often think of it as those are the teams that have the highest ceiling in terms of performance improvement. And with your responses, we can actually highlight 3 DevOps technical, process, measurement, or cultural capabilities that can help improve your overall software delivery performance. And if you want to dig a little further, you can actually go and answer some additional questions, which will help you prioritize and determine which capability specifically would have the most positive impact. And now when comparing elite performers to all other categories, we found that elite teams are over 200 times more, they do over 200 times more frequent code deployments. They're 100 times faster at going from commit to production. They ship 1/7 the number of changes that lead to failures. And they're 2,600 times faster at recovering from a failure scenario, which is pretty amazing. What's even wilder, though, is with the 2021 State of DevOps report, we saw some significant changes driven by increased performance across the board. Elite performers pulled further ahead in 3 out of the 4 metrics. So they were doing 973 times more frequent code deployments. And with lead time from commit to deploy and time to restore, they went over 6,000 times faster. But with the change fail rate, you'll notice that gap has actually gotten noticeably smaller. Now, we think this is due to a variety of factors, but in particular, with all the challenges we had through 2021, we think that elite teams kind of maintained some of the pace they had in some areas. And I think some of the other categories of teams maybe slowed down the pace of innovation and focused way more on stability. So they shipped fewer failures. So they were actually able to kind of reduce that gap a little bit in terms of the failures they shipped via the change fail rate. Now, what we started to understand with all this data is that stability and velocity are actually really closely intertwined. In fact, they reinforce themselves. They're not a trade-off, right? You have to make. Now, it seems counterintuitive at first, right? You would think that if you increase velocity, you're also going to decrease quality. But again, the data shows us that as velocity increases, so does reliability. And in fact, we see this with elite teams. They score really high on both speed and stability metrics. So you might be wondering how that's possible. Well, we have a partial explanation. We measure that velocity, that speed, in terms of the interval from when code is committed to when it's deployed in production. Now, one of the key ways that this is accomplished is a technique learned from lean manufacturing, right? Working in small batches. Those little increments of code continuously moving through the pipeline, right? And the smaller the change delta, the easier it is to review and the easier it is to understand its implications, and the easier it is to roll back if there's a problem. So in a way, we can actually work on really, really small changes, and it becomes much easier to make its way all the way through to production and pull back if we need to. So there is an underlying mechanism that is really driving both sets of metrics. Now, DORA applies a whole bunch of predictive analyses to identify specific DevOps capabilities that are associated with high-performing teams. Now, the research program looked into more than 30 different sort of unique DevOps capabilities, and they kind of fall into a whole bunch of different categories, right? Things like cloud usage, reliability, security, leadership. But when we zoomed out, what we found is that we were able to kind of group them into 4 better buckets, right? Process, technical, measurement, and culture. And the research showed us which DevOps capabilities were predictive, right? Or had a really positive impact on which outcome. And so this analysis actually gives us a whole bunch of insights in terms of where to invest and, frankly, where not to invest. Now, we've taken all those 30 plus capabilities, and using all this data that we've got from the last several years of surveys, we were able to see which capabilities have that positive impact on others and which have the negative impact. And again, I know this diagram is really hard to read through because it's pretty small, but if you hit that link at bit.ly/DORA-BFD, that stands for Big Friendly Diagram, you can see a dynamic version of the diagram and dig into each capability and what it's related to. But let's take a little bit of a deeper dive here on another slide. So here's a subset of that larger diagram. Now, starting over at the right, we want to focus on improvements to organizational performance, which we know, again, through this data, that it's driven by software delivery and operations performance. Well, that is in turn positively impacted by 2 things: continuous delivery capabilities, as well as people and process improvements. And that's reflected in culture and in work environment. Now, we know that continuous delivery also has a huge positive impact on toil reduction. And that really means just reducing rework, reducing the pain of deployments, and frankly, reducing burnout overall. And continuous delivery and culture and work environment are directly impacted positively by a number of DORA identified DevOps capabilities. And so you can actually see that there is way more to DevOps than just implementing a new CI/CD pipeline. It goes much deeper and further than that, right? When we think about culture and work environment, we want to see things like blameless retrospectives and streamlined change processes, or giving our teams more autonomy. And in terms of things like continuous delivery, that tends to imply that we've made a good investment in moving security to be evaluated every step of the way, or having a loosely coupled architecture, or having a whole bunch of deployment automation. Now, we don't have time to go through all of 30 plus of the DORA capabilities, but I'll leave that to y'all with some homework later on. So we have methods to measure delivery performance, and we know what capabilities drive those performance improvements. So now what we need to do is examine how best we can apply this research using high-quality DevOps outcomes. So over the next few months, we'll be diving into these DevOps outcomes and show how you can achieve them using Google Cloud Infrastructure. For now, I want to give you a little teaser about each of these outcomes and how they help improve software delivery performance. The first outcome is infrastructure as code. Now, this is much more than just having kind of a pile of Terraform scripts laying around. Infrastructure as code is actually really about automating the complete lifecycle of platforms and applications. And that means including aspects starting with, again, that declarative configuration. We've got to start from there. But then incorporating some level of policy evaluation and enforcement. And we want to enforce and evaluate things like, can I deploy this VM? Or can I configure this load balancer? And then from there, we need to distinguish between application infrastructure and base infrastructure. And you can think of that difference as, where my code's running and sort of what it's running on, right? That's sort of the distinction between those two. And the final component that ties it all together is automation, right? And this is where a lot of teams typically will have maybe manual steps or maybe some automation and some manual. But that's what we really want to unpack. And we need to figure out if the infrastructure as code approach that you're using, does it scale to every single technical team in your organization? Now, if you go back to the 4 key metrics, a solid infrastructure as code approach has a real clear direct through line to things like deployment frequency and lead time from commit to release, as well as a pretty positive impact on time to restore. And because we have a fully automated approach here, it has a secondary impact on reducing your change fail rate. I mean, if you think about it this way, consider if you've got all this automation and this ability to spin up deployments really quickly, spinning up test environments that look like prod is really easy, which means running tests in environments that closely match or approximate your production environment becomes much easier to do. And that's how you can start to positively impact things like change fail rate, because you can test in much more closely modeled environments. Now, the second outcome we'll dig into is all about reliability. We'll talk about what it means and how you can adopt reliability practices for all of your services. When we talk about reliability at Google, we're usually talking about site reliability engineering or SRE practices. Now, I don't want to oversimplify, but in my head, I often distill SRE down to some major themes. And to be absolutely clear, I am blowing way past a lot of detail, really good detail about SRE. But for now, I want to focus on just the high points. First and foremost, the experience of our end users should be the driving factor in determining reliability, not our monitoring metrics. Because to be frank with you, it doesn't matter how great the software is or how much CPU we're not using. It's if folks can't use the software, right? If it doesn't work for them. Which means we need to also shift our thinking from thinking about things like hardware and VMs and containers and move them simply to a different abstraction that's just services, not full-blown applications. Because as it turns out, services are really the most accurate abstraction that really reflect what users interact with. For example, users don't interact directly with the VMs that your software runs on. They interact with the web application front end, right? So we want to start grouping things like that. And finally, that means that traditional metrics like CPU, RAM, disk usage, they're not really effective proxies for reliability because they don't proxy that user feeling. We need to focus instead on what, again, users see and feel in our applications, in our services. That means we need to look at things like request and response latency, service availability, and things like network throughput and service saturation. These are the indicators that will probably allow us to quantify how a service feels to an end user much more closely than your typical monitoring metrics. Which then leads us right into more formal SRE approaches. SLAs, SLOs, and SLIs. And we're going to start from the bottom and go up. So think of SLIs as the important metrics, which we've already talked about, right? Latency, availability, saturation, and throughput. SLOs are the goals we want to achieve for those indicators. So things like 99% uptime or availability, or 95% of all requests that must come in below 1,000 milliseconds, those sorts of things. And finally, SLAs are the promises we make to our end customers and what we agree to give them if we don't achieve our goals. So for example, you may have a situation where you run a service and your SLA could include, hey, if we violate our SLO, we promise to give you cloud credits or credits to kind of offset that spend. Now, there's certainly way more to SRE than all of this on this slide, but we've covered some of the important bits to start. And when we go in depth on this topic, we'll go through the practices and the tools that we have inside of Google Cloud to help you adopt an SRE-centric approach. And again, when it comes to DORA, reliability has direct ties to change failure rate and time to restore. And if you think about it, if we truly know how to measure reliability and we really understand our software and our services and how those reliability metrics come into play, we actually get better at testing and shipping our software over time, and we have a better ability at remediating those issues over time as well. So the next outcome is software delivery pipelines. And if you can tell, we're kind of moving up the stack, right? From infrastructure as code to reliable services and now kind of getting to software delivery of applications. And this is mainly about CI and CD. How do you do it using Google Cloud? Well, when we talk about software development and delivery, we typically discuss it in 3 phases: code, build, and run. Here we're going to dig deeper into the build phase and talk about the distinction between building, storing, and deploying artifacts. And those artifacts could be anything from VM machine images to software packages and jar files to containers. The goal here is to dissect the standard cloud native delivery process and then map it back to Google Cloud. And along with that, I want to go in depth on artifact management and deployment strategies. Now, from a DORA perspective, these tools help us directly address metrics like lead time from commit to production and change failure rate. And really, that's the value of having a whole bunch of automation and evaluation that we can build into our delivery pipelines. The final outcome we'll talk about is an extension of software delivery, and that's really focused solely on the security aspects. Now, one of the key DORA capabilities I had mentioned earlier is all about shifting security to the left. And that means we bring security evaluation and enforcement much earlier into the development process. It's not about checking things out at runtime and making sure they're safe. We want to catch the bad stuff before it even happens. So now we say this all the time, but it continues to be true. Software is difficult and complex. And we continually push more and more complexity into the development process. But we can start to address this by focusing on software supply chain security. Think of the software supply chain as a way of kind of mapping out the development and delivery process, but this time accounting for all of the dependencies and the systems and validity and trust that needs to happen to make it all work together. So that means at each level or at every step, we need security controls and compliance checks because there are many possible vectors for attack. Now, we're not going to have time to go through all of these, but you could imagine things like injecting bad code, compromising your build system, or even having a bad or a vulnerable dependency included in your software. So there's a lot of places where, the surface area for attack is pretty large. Now, if we can solve for this, we can kind of continue building upon the speed metrics from software delivery and get some stability out of this as well by reducing our change failure rate. Now, for each of these outcomes that I talked about, infrastructure as code, running reliable services, software delivery, and securing the software supply chain, we'll be mapping them back to specific DORA DevOps capabilities. And we'll be answering the question of how can we apply what we've learned from DORA to those DevOps outcomes using Google Cloud. And finally, we'll examine how each of these outcomes addresses the 4 key metrics we talked about earlier. But before we close, as promised, I have a little bit of homework for each of you. First thing I want y'all to do is go read the 2021 State of DevOps Report. You can find it at bit.ly/DORA-SODR. It's got a lot more background, and it talks about a whole host of important DevOps findings that we don't have time to cover today. And it covers things like, where does cloud fit in? Or is reliability really important? Or what kind of differences do good documentation make? And much, much more. It's definitely worth a read, and I think it'll give you a sense for the language we'll be using over the next few months as we talk about all these DevOps outcomes. The second thing I'd like you to do is go and do the DORA Quick Check, which is available at bit.ly/DORA-QuickCheck. You can save the link from your results, and that'll let you repopulate them and refer back to it when we meet again in a month. But it'd be great if y'all want to share things like which DevOps capabilities were identified that you were told would be the most helpful. Which ones were prioritized for you. So that's all I wanted to cover for today. Just give you a sense for what's coming, and I'll see all of you in a month when we talk about applying DORA to infrastructure as code. Thank you.